All right, so welcome to my problem 26.20. This will be the practice problem of my week 5 video explainers. So in this problem, we are told that the light from the sun allows a solar cell to move electrons from the positive to the negative terminal, and in doing so, it's going to be 3.2 times 10 to the negative 19th joules of work per electron. And we're trying to find the EMF, or the electromotive force, and this electromotive force is going to be the energy per unit electric charge that is going to be imparted off by an energy source. So in this case, we're dealing with a sun and a solar cell. Now that we've kind of outlined exactly what the electromotive force is, we can use some equations and rearrange them to ultimately find out this electromotive force. So we know that the work, the work done by these electrons is going to be equal to the negative change in the potential energy. And additionally, we know that the change in potential of the electron is going to be given by the charge times the delta V. In this case, that will be ultimately the EMF, or the electromotive force, this change in potential of the solar cell. So what we're going to do in this next step is we are going to substitute the charge times the change in potential, or this delta V, for delta U, because we are ultimately solving for delta V, or the EMF. So now we're going to get the work is going to be equal to the negative charge times delta V. And one thing to note is that since the electron is moving from positive to negative the positive to the negative terminals, this potential difference between the two terminals is equal to the EMF of the solar cell. So that's why that potential difference, delta V, is going to be ultimately what we are solving for. So now we're going to, in this next step, we're going to rearrange the equation to isolate delta V, and we know, so after doing that, that's going to be equal to the negative work over the charge of the electron. And being that we were given the work, and we know that the charge of the electron is going to be negative 1.6 times 10 to the negative 19th coulombs, we ultimately find out that this EMF value is going to be equal to 2 volts. So some of the tricky parts, I guess, was just finding the equations, what to use, understanding that this change in potential is going to be equal to this electromotive force. And I guess what some of the equations tell us is that the work done per an electron is equal to the negative of the product of the charge on the electron, and in this case, in the electromotive force of the solar cell. So that's what these equations tell us, and this is just an example of how we relate work, charge, and potential difference, and try to figure out how those are all kind of intertwined, and ultimately solving for one by understanding how the others work with each other. So yeah, thank you very much.